Immersing ourselves in the vastness of the universe, we humans have always questioned whether we are the only species gazing at the stars, contemplating distant galaxies, and exploring the potential for life beyond our little blue planet. That potential has finally materialized. NASA's director has just announced that the James Webb Space Telescope has captured something extraordinary at the edge of our cosmic neighborhood. The James Webb Telescope has zeroed in on Proxima b, the closest potentially habitable exoplanet to Earth. We recall that a possible city created by intelligent life had been detected, which to date we do not know for sure. The recent James Webb discovery shows how the brightness of the artificial lights of the city on Proxima b has increased. In addition, the chemical composition of the atmosphere of this exoplanet has been discovered. Join us on this incredible journey to Proxima b to discover the details of this discovery. According to NASA's director, the James Webb Telescope may have used all its technology effectively and has detected life on Proxima b, an exoplanet located just 4.24 light-years from our solar system. Proxima b has become a phenomenon of fame due to its potential to be habitable. This exoplanet orbits its parent star Proxima Centauri, a red dwarf that is much smaller and cooler than our Sun. Discovered in 2016, Proxima b lies in the star's habitable zone, also known as the Goldilocks zone, which is the region around the star where conditions could allow the presence of liquid water, a crucial ingredient for life as we know it. Proxima b's proximity to Earth and its location within the habitable zone have generated enormous interest and speculation about its ability to support life. However, it is important to keep in mind that the habitability of an exoplanet is a complex puzzle involving numerous factors. Proxima b is classified as an exoplanet with a mass approximately 1.3 times that of the Earth and has an orbital period of approximately 11.2 Earth days, meaning that it completes one orbit around Proxima Centauri in that time. However, things are not as simple as we may think. The fact that the planet is Earth-like in size and orbits a red dwarf does not guarantee that it is an exact replica of our world and that we can all move there. The habitability of Proxima b is determined by multiple factors. One of them is the planet's atmosphere, which acts as a protective shield and plays a crucial role in regulating temperature and life in general. However, the exact composition of Proxima b's atmosphere is still unknown, making it difficult to definitively determine its habitability. Scientists are working on methods to study the atmosphere of Proxima b, and a key tool in this process is the James Webb Space Telescope. This telescope will allow scientists to analyze the light that passes through the exoplanet's atmosphere during transits, which will give them information about spectral characteristics and help them search for possible biomarker molecules that could indicate the presence of life. Another important factor affecting habitability is the presence of water. Although Proxima b is within the habitable zone, it is crucial to determine whether it has a sufficient amount of water to be considered suitable for life. Water is a critical piece of the puzzle, and scientists are looking for signs of liquid water on the planet's surface, whether in the form of oceans, lakes, or rivers. These clues could be key to assessing the possibility of habitability on Proxima b. The presence of water in other states, such as ice or vapor, is also considered because water availability is essential to support biological processes and is considered a key indicator of habitability. The presence of Proxima b raises questions about its climate. Scientists must also investigate factors such as temperature, pressure, and geological activity on Proxima b to assess whether the planet is within a suitable range for life to thrive. Extreme conditions, such as scorching heat or extreme cold, can make survival difficult. Stability is also crucial. Volcanic eruptions or seismic activity can disrupt habitability, but stability is a good sign. Proxima b is believed to be in a tidally locked state, meaning that one side of the planet remains permanently in darkness while the other side is permanently illuminated by the star. The stark contrast between the illuminated and dark sides could generate temperature variations and dynamics that could affect the planet's habitability. These are just some aspects that scientists are considering in the search for habitable planets. Scientists are investigating the chemical composition of Proxima b to analyze the presence of organic compounds such as amino acids and other molecules essential for life. They are also examining whether the planet receives enough energy from the star or other sources to fuel biological processes and allow organisms to grow, reproduce, and thrive. However, despite all these studies, the question arises as to whether Proxima b actually possesses all the necessary elements to be considered a habitable planet. Is there concrete evidence for this? The discovery of Proxima b in 2016 was a remarkable achievement. Astronomers used a high-precision instrument called the High-Accuracy Radial Velocity Planet Searcher, or HARPS for short, to detect the subtle gravitational tug of an exoplanet around Proxima Centauri, our nearest neighboring star. This high-precision spectrograph is designed specifically to detect exoplanets and operates at the La Silla Observatory in Chile. It has been crucial in the discovery of numerous exoplanets, including Proxima b. The HARPS instrument operates using the radial velocity method, also known as the Doppler spectroscopy technique. Its function is to detect exoplanets by measuring the subtle shifts in the star's spectrum caused by the gravitational pull of an orbiting planet. These shifts, known as radial velocity or Doppler effect, occur due to the slight wobble of the star as it is dragged by the gravitational interaction with its companion planet. HARPS has an optical fiber that collects the light from the target star and directs it to the internal spectrograph. Inside the spectrograph, the light is dispersed into its different wavelengths, allowing astronomers to study the star's spectrum in detail. In this way, scientists can determine the star's radial velocity with exceptional accuracy. To achieve the high level of precision required for exoplanet detection, HARPS uses technologies and techniques that include a temperature-controlled environment. This allows stabilizing the instrument and minimizing the effects of thermal variations that could interfere with accurate measurements. Proxima b is an Earth-like planet orbiting the closest star to our solar system. While conditions on Earth are quite suitable for life, why settle for that when there are other planets that offer better characteristics, such as balanced temperatures, fewer deserts, and a greater abundance of water? We're talking about the future of humanity, and scientists have identified some planets as prime candidates for possible colonization. These superhabitable planets, as Michio Kaku calls them, are fascinating and offer exciting possibilities for our future. Michio Kaku, the renowned physicist and co-founder of string theory, is optimistic about the future of humanity and the possibilities and opportunities that these superhabitable planets may offer. He firmly believes in the possibility of achieving immortality, and furthermore, he has speculated that in the future we will be able to colonize other planets and even entire universes. This idea arises due to the need to have settlements in place in case something catastrophic happens on Earth, such as a meteor impact, supervolcanoes, or ice ages. In about 5 billion years, it is even predicted that the Sun will expand and consume Earth. The first step to ensure our survival is to leave Earth and start colonizing other planets in our galaxy. The goal is to find Earth-like planets or even better planets called superhabitable planets that have even greater potential to harbor life than our own home. The term superhabitable planet was proposed in 2014 by Renee Heller and John Armstrong. According to them, the mere location of a planet within the habitable zone of its star is not enough to determine its actual habitability. Superhabitable planets are specific celestial bodies that offer a higher potential for harboring life compared to Earth. The common belief is that Earth, as the only known planet with life, meets the primary requirement for habitability, the presence of liquid water. For this reason, we search for a planet similar to Earth in the hope of finding places where life can also exist. However, it is important to recognize that other types of planets may offer conditions equal to or even more conducive to life compared to Earth. Contrary to the notion that Earth represents the pinnacle of planetary habitability, a superhabitable world could also be a moon with a richer range of flora or fauna compared to our own planet. Such a world would be shown as a higher degree of environment conducive to life. It is also important to note that not all rocky planets located in the habitable zone of a star are automatically habitable. Habitability depends on a variety of factors and is not limited solely to similarities with Earth. The concept of superhabitable planets can be complicated to convey as it challenges the assumption that Earth represents the pinnacle of planetary habitability. However, it is important to consider that our planet harbors an impressive array of complex and diverse life forms, suggesting that life can thrive in conditions very different from those on Earth. In the search for exoplanets, researchers need to explore indicators that may reveal the existence of superhabitable worlds.